Our ancestors saw the universe with a clarity that rivals our own. This video reveals 20 unearthed artifacts that prove ancient civilizations possessed a stunningly advanced understanding of the cosmos. You will discover how a 2,000-year-old bronze machine predicted eclipses and why massive desert drawings align with distant stars. These findings challenge everything we thought we knew about the timeline of human knowledge. They suggest a forgotten scientific sophistication woven into the fabric of ancient life. How much of our history is still waiting to be decoded? That corroded bronze device pulled from a Greek shipwreck did more than just tell time. It mapped the heavens with a sophistication that would not be seen again for over 1,000 years. The Antikythera Mechanism is a complex clockwork of at least 30 interlocking bronze gears, housed in a wooden case no larger than a shoebox. When its hand crank was turned, these gears moved dials and pointers across several faces, predicting the movements of the sun, the moon, and the 5 planets known to the ancient Greeks. It was a portable cosmos, an entire astronomical observatory you could hold in your hands. One of its most brilliant features was a small, rotating ball, painted half white and half black, that spun to show the exact phase of the moon on any given date. It even accounted for the subtle wobble in the moon's orbit, a complex motion called precession, proving its builders possessed not just observational data but deep mathematical insight. This machine could also forecast eclipses, not as random acts of the gods, but as predictable, calculable events. The mechanism even included a dial tracking the 4-year cycle of the Olympic Games, weaving the rhythm of human celebration directly into the fabric of celestial time. How was such precision achieved without the tools we take for granted? The existence of the Antikythera Mechanism suggests a forgotten lineage of engineering genius, a school of thought whose other works were lost to the depths of the sea or the dust of time. It stands as a stunning rebuttal to any idea of linear progress, forcing us to ask what other sophisticated knowledge was simply waiting to be rediscovered. That same sophistication was not confined to the Mediterranean. In a forest in Germany, a treasure hunter's discovery would radically alter our view of Northern Europe's Bronze Age. He unearthed a bronze disk inlaid with gold symbols of a crescent moon, a full sun, and a cluster of stars. Mistaken at first for a medieval shield decoration, scientific analysis revealed its true age, dating it to around 1,600 years before the Common Era. This is the Nebra Sky Disk, the oldest known portable map of the night sky. It is not a simple picture. The arrangement of stars is precise, with a tight cluster representing the Pleiades, a group of stars important to agricultural societies across the ancient world. Flanking the disk are 2 golden arcs, added later by its creators. These arcs mark the precise points on the horizon where the sun would rise and set between the winter and summer solstices. Archaeologists like Harold Meller see it as a sophisticated astronomical calculator. By lining up the disk with the actual sky, a community could determine the correct time to plant or harvest, synchronizing their lunar calendar with the solar year. Later, another golden arc was added to the bottom, interpreted as a solar barge, a mythical boat believed to carry the sun across the sky each night. This single object beautifully merges hard science with deep spirituality. It was a practical tool for survival and a sacred object that connected daily life to the grand cycles of the cosmos. The disk invites us to see the world through their eyes, where the movement of the stars directly dictated the rhythm of community life, blending observation and belief into a single, shimmering bronze disk. This physical mapping of the heavens in metal finds a much larger, more permanent expression in our next artifact, one carved not into a portable disk, but into the very landscape of the desert. Far from the forests of Germany, in the humid lowlands of Mesoamerica, another civilization was perfecting its own cosmic language. The Maya Dresden Codex is a single, surviving book from a vast library of knowledge, a fragile manuscript of bark paper folded like a screen. While European texts of the same era were often focused on theology, this codex reads like a sophisticated astronomical almanac. Its pages are filled with precise charts and complex calculations, a testament to the Maya obsession with tracking the cycles of time and the movements of the heavens. They achieved a level of accuracy that feels almost impossible without modern instruments, predicting the appearances of Venus with an error of just 1 day in 500 years. This was not merely stargazing, it was a high science dedicated to synchronizing human life with the celestial clock. The Codex contains a detailed Venus table spanning 104 years. For the Maya, Venus was more than a bright star. It was a powerful deity whose movements directly influenced the fate of kings and the outcomes of war. The tables in the Codex told priests exactly when the planet would rise as the morning or evening star, events that were often linked to the timing of royal ceremonies or military campaigns. A page might show that the appearance of Venus in a certain position signaled a time for conflict, while its disappearance into the sun's glare suggested a period for planting and renewal. This was astronomy deeply woven into the fabric of statecraft and spirituality. The Codex also contains tables for predicting solar eclipses and tracking the less predictable movements of Mars, demonstrating a surprisingly broad understanding of planetary periods. Scholars like Anthony Aveni point to the immense dedication required to compile this data. It represents observations meticulously recorded and refined over countless generations. How did they maintain such a consistent and long-term research program, passing down this exacting knowledge from priest to scribe for centuries? The Codex opens a direct window into the Mesoamerican intellect, revealing a culture that saw the universe as a complex, orderly system that could be understood, predicted, and respectfully engaged with through ritual. This blend of precise mathematics and profound mythology shows a worldview where numbers held divine power and the sky was a living text to be read. As we move further into the Americas, we find another culture that mapped this celestial text not on paper, but across an immense and arid landscape. High atop the Andean peaks, shrouded in cloud, a granite pillar stands as a silent sentinel to a lost cosmic science. This is the Intihuatana at Machu Picchu, the hitching post of the sun. Carved by Inca hands in the 15th century, this was no ordinary stone. Its surfaces were precisely angled and its edges aligned to the sun's annual journey across the sky. During the solstices, the sun would strike the pillar so perfectly that it cast no shadow at all, a moment of celestial equilibrium that held immense spiritual power. Researchers like Johann Reinhard interpret this as the Inca's ultimate act of cosmic harmony, a ritual to symbolically tether the sun to the earth and ensure its return after the shortest day of winter. It was a profound declaration that humanity had a role to play in maintaining the balance of the universe. This stone served as both a sophisticated observatory and a sacred altar. Priests would have used the shifting shadows throughout the year to mark the equinoxes, signaling the optimal times for planting and harvesting in the steep terraces below. The stone's orientation also aligns with sacred mountain peaks, or apus, which were considered powerful deities in Inca cosmology. This created a tangible link between the celestial realm, the earthly plane of human activity, and the spiritual world of the mountains. Every astronomical observation was therefore a ceremonial act, every calculation a prayer. How did a civilization without formal written records encode such precise and enduring knowledge directly into the living rock? The Intihuatana embodies a world where science and spirituality were not separate disciplines, but two sides of the same coin, a deep understanding that to track the heavens was to commune with the divine. This seamless integration of architecture, astronomy, and belief finds a powerful echo in another culture that also built monuments to last for eternity along the banks of the Nile. While the Inca carved their cosmos into mountain stone, another civilization painted theirs upon a temple ceiling. High on a chapel roof in the Egyptian temple of Hathor at Dendera, a massive sandstone relief presents one of the most complete ancient maps of the night sky. The Dendera Zodiac, created around the 1st century before the Common Era, is a breathtaking fusion of astronomical knowledge. It is a circular chart, a detailed celestial planisphere carved with exquisite care. Here, the familiar figures of the Babylonian zodiac, like Taurus the bull and Leo the lion, stand alongside purely Egyptian constellations and deities. The sky goddess Nut is shown stretching across the heavens, a powerful symbol of the celestial vault from the oldest Egyptian traditions. Scattered among the constellations are the planets, depicted as wandering gods, and 36 small figures known as decans, each representing a star group that rose to mark a 10-day period, forming a sophisticated ancient clock. Egyptologists like Sylvie Coville believe this stone sky was far more than decoration. It served as a complex calendar and a divine guide for temple rituals. The positions of the sun, moon, and planets within this carved zodiac likely dictated the timing of sacred ceremonies dedicated to the goddess Hathor. The relief even includes symbolic depictions of eclipses, showing a circle containing a baboon, the Egyptian god Thoth, swallowing the moon's disk. This was a tool for prediction, allowing priests to anticipate celestial events and interpret their meaning for the kingdom. What makes the Dendera Zodiac so compelling is its cultural hybridity. It is not purely Egyptian nor purely Greek, but a brilliant synthesis, proving that knowledge flowed freely across the ancient Mediterranean world. This artifact speaks of a shared human project to understand the cosmos, where ideas from Mesopotamia and Greece were absorbed and reimagined through an Egyptian spiritual lens. It challenges the notion of isolated ancient cultures, revealing instead a network of intellectual exchange. What other secrets of cross-cultural collaboration are hidden in plain sight, waiting on a temple wall or buried in a forgotten text? This journey to map the stars now takes us to a far colder and wetter landscape, where a ring of towering stones holds its own silent conversation with the sky. The bluestones of Stonehenge hold a secret written not in words, but in their very origin. Quarried from the Preseli Hills in Wales, these distinctive spotted dolerite rocks were transported an astonishing 150 miles to the Salisbury Plain, a logistical feat that defies easy explanation. Why would a Bronze Age community commit such staggering effort? The answer appears to be written in the sky itself. Arranged within the larger circle of sarsen stones, the blue stones form a key part of an architectural machine designed to track the cosmos. The entire monument is oriented to capture the sun's most dramatic moments. At dawn on the summer solstice, the sun rises directly over the outlying heel stone, casting its long beam into the heart of the stone circle. But this was more than a solar calendar. Archaeologist Mike Parker Pearson and his team suggest the arrangement also meticulously tracked the complex, 18.6-year cycle of the moon. The 56 Aubrey holes, a ring of pits just inside the bank, may have been used as a primitive astronomical computer. By moving markers from hole to hole, priests could have predicted lunar eclipses, events that would have held immense, perhaps terrifying, power for the people who witnessed them. This was a society that organized its entire communal life, its agriculture, and its most sacred ceremonies around the reliable rhythm of the heavens. The immense labor of moving the blue stones, a project spanning generations, speaks to a profound collective belief in cosmic order. It was an act of faith made stone, a declaration that human survival depended on aligning with the greater universe. This deep connection between landscape, stone, and sky finds a parallel in another ancient culture, one that also built its celestial clock on a monumental scale. An earthwork hidden in a German field for millennia reveals an even earlier chapter in humanity's cosmic story. The Goseck Circle is a Neolithic enclosure, a series of concentric ditches and wooden palisades built around 4900 BC. This makes it one of the oldest known structures on Earth deliberately designed for observing the sky. From the air, its pattern is unmistakable, a giant geometric footprint stamped into the landscape. Its design was not random. Two opposing gates in the circular palisade align with breathtaking precision to the rising and setting sun on the winter solstice. On that shortest day of the year, a person standing at the center of the circle would have watched the sun's first and last rays slice directly through these narrow southern apertures, marking the pivotal moment when the days would begin to grow long again. Researchers like Francois Berthimes see this as a sophisticated solar observatory, a massive calendar constructed by early farming communities who depended on knowing the seasons for their survival. The accurate timing of planting and harvesting was a matter of life and death, and the circle provided that crucial data on a monumental scale, but it was likely more than just a practical tool. The discovery of pottery shards and evidence of fires suggests this was also a place of ritual, where the community gathered to witness the sun's symbolic rebirth. This linking of cosmic cycles to daily life and spiritual practice reveals a deep, intuitive understanding of the universe's rhythms. How did these early societies, without written language or complex mathematics, achieve such precise alignments and encode this knowledge into their architecture? It speaks to a profound human ingenuity, a capacity for careful observation and communal memory that allowed them to build a functioning astronomical instrument out of earth and wood. The Goseck Circle is not alone. It is part of a wider tradition of such enclosures found across Europe, pointing to a shared, ancient yearning to connect with the heavens. This desire to capture celestial patterns finds a new expression far to the east, where artisans forged a permanent record of the stars not in soil, but in shimmering bronze. 1,000 years before the Goseck Circle, another culture was crafting its vision of the sun's journey from an entirely different material. In a Danish peat bog, a small, stunning artifact emerged from the earth, a sculpture of profound elegance and cosmic meaning. The Trundholm Sun Chariot dates to around 1400 years before the Common Era. It is a bronze statue of a horse pulling a 6-wheeled chariot, and upon that chariot rests a large, gleaming disc plated with thin gold. One side of the disc is brilliantly gilded, while the other is left as plain, dark bronze. This is no simple decorative piece. Scholars like Fleming Call interpret it as a sophisticated cosmological model, a physical representation of a myth that explained the sun's daily passage. The golden side represents the sun as we see it crossing the sky by day, pulled by a divine horse. The bronze side, however, signifies the sun's invisible nighttime journey back to the east through the underworld to begin its cycle anew at dawn. The entire object is a narrative of perpetual renewal. Intricate spiral patterns are engraved across the disc and the horse, designs that may symbolize the sun's cyclical path or the turning of the seasons. This was likely more than a representation. It was a ritual object. One can envision it being used in ceremonies, perhaps wheeled in a procession to mimic the sun's own path, a powerful act of sympathetic magic intended to ensure the sun's victorious return after the long, dark winter. It embodies a worldview where the cosmos was not a cold, mechanical system, but a living story in which humanity played an active, participatory role. The chariot reminds us that for our ancestors, understanding the heavens was not just about tracking time. It was about comprehending a divine drama that unfolded above them every single day and night. This beautiful fusion of art, astronomy, and mythology finds a powerful parallel in another ancient culture, one that also saw the sun not as a distant ball of fire, but as a deity requiring a vessel for its journey. Stretching across the stark, arid plains of southern Peru, a giant spider seems to crawl over the desert floor. This is not a random sketch, but one of the most intricate Nazca geoglyphs, a figure so vast its full form can only be comprehended from the sky above. Created by the Nazca culture over a 1,000-year period, these immense lines etched into the earth were far more than art. Researchers like Maria Reich dedicated their lives to understanding them, proposing that many of these designs, including the spider, functioned as a colossal astronomical calendar. The spider's long, slender legs are not arranged randomly. They are precisely aligned with the rising and setting of specific stars, possibly within the constellation of Orion. For a people living in one of the driest places on Earth, tracking celestial movements was a matter of survival, directly linked to predicting seasonal rains. The appearance of certain stars on the horizon would signal the coming of moisture from the Andes, the lifeblood for their agriculture. The geoglyph, then, was a sacred map, a way to synchronize their rituals and planting cycles with the dependable rhythm of the cosmos. How did they achieve such staggering precision without the ability to fly? The Nazca surveyors used simple but brilliantly effective tools, likely citing poles and ropes, to plot these perfect lines and curves across miles of terrain, transferring a small-scale design into a landscape-sized masterpiece through geometric mastery and generations of shared knowledge. This fusion of art, science, and spirituality, writ large upon the earth itself, demonstrates a profound desire to anchor human life to the heavens. From this vast desert canvas, our search for ancient cosmic understanding leads us to a single, enigmatic object crafted from crystal and stone. While the Nazca marked the desert with giant symbols, another civilization was encoding the cosmos onto small tablets of wet clay. In the royal libraries of ancient Mesopotamia, the Venus tablet of Ammisaduqa offers a different kind of celestial record. This cuneiform tablet, dating to the 7th century before the Common Era, is part of a much larger series of texts known as Enuma Anu Enlil. It meticulously documents the movements of the planet Venus over a 21-year period during the reign of King Ammisaduqa. The data is astonishingly precise, tracking the planet's cycles of appearance and disappearance as the morning and evening star. Scholars like Otto Neugebauer have shown that the Babylonian astronomers calculated the planet's synodic period, the time it takes to return to the same position relative to the sun, with remarkable accuracy. But this was far more than a scientific log. Each celestial event was directly linked to an omen, a prediction for events on Earth. The tablet might state that when Venus disappeared in the east on a certain day, it signaled a coming period of conflict for the kingdom. If it reappeared in the west with particular brilliance, it might foretell a bountiful harvest. This created a powerful feedback loop where the sky was a divine text and the king's scribes were its interpreters. The movements of Venus directly influenced state decisions, from the timing of military campaigns to the legitimacy of the king himself. How did they maintain such a consistent, long-term observational program spanning generations? It speaks to a highly organized priestly class dedicated to the systematic recording of the heavens, treating astronomy as both a sacred duty and a tool of governance. This tablet reveals a culture that saw no separation between the laws of the cosmos and the fate of its people, a world where mathematics and mythology were intertwined to guide an empire. This systematic approach to the stars finds a mysterious counterpart in a civilization that left no such written records, the enigmatic culture of the Indus Valley. A world away from the written records of Babylon, the Indus Valley civilization left its wisdom in more enigmatic forms. Within the ruins of Mohenjo-Daro, a small, square seal carved from polished steatite offers a silent, profound mystery. It depicts a seated figure in a calm, meditative pose, wearing a headdress adorned with circular elements and what appears to be a pair of horns. This is the so-called priest king, and while his true identity is lost, his seal speaks volumes. The symbols surrounding him are not random decorations. Researchers like Jonathan Mark Kenoyer propose that the circular motifs on his headdress could represent stars, while the mythical unicorn-like creature depicted on many such seals may itself be a symbolic representation of a celestial body, perhaps a planet or a significant constellation. This was a society built on remarkable order and planning, with precisely laid out cities and sophisticated water systems, a culture that clearly valued harmony and balance. It is not difficult to imagine that this sense of earthly order extended to the heavens. Could this seal have been used to stamp documents or goods, its celestial imagery signifying authority derived from an understanding of cosmic cycles? Perhaps it was used in rituals to ensure that community decisions were aligned with the movements of the stars, weaving astronomy directly into the fabric of governance and spiritual life. The seal does not give us clear answers, but it powerfully suggests that the people of the Indus Valley saw their world as part of a larger, orderly cosmos. Their understanding was not carved in giant monuments or written on clay tablets, but encoded into the small, personal objects of their daily existence. This subtle integration of the cosmic and the commonplace finds a dramatic contrast in our next artifact, one that emerges from the vast expanse of the Pacific Ocean, where an entire culture navigated the open sea using nothing but the stars as their guide. The vast Pacific Ocean was not a barrier, but a mapped highway for Polynesian voyagers. They navigated thousands of miles across open water using charts crafted not from paper, but from wooden sticks and cowrie shells. These are the Polynesian stick charts, intricate frames that physically modeled the ocean's hidden rhythms. A chart known as the Matang type was not a map of land, but a teaching device, a schematic diagram of how swells bent around distant islands. The shells represented islands, while the curved sticks illustrated the complex interference patterns of waves, refracted and reflected by unseen atolls far beyond the horizon. Navigators learned to feel these patterns through the hull of their canoes, reading the ocean as if it were a textured page, but this was only half the system. As researcher David Lewis documented, these physical charts were paired with an encyclopedic oral tradition that mapped the sky. Navigators memorized the rising and setting points of hundreds of stars, using them as celestial compass points. The constellation we call the Southern Cross, known to them, was a crucial southern marker. A voyage from one island to another was conceived as moving beneath a specific succession of stars, a star path that held true across the immense, featureless sea. They understood that the ocean had its own constellations, written in the swells and the stars above. How did they first decode this liquid language, learning to see patterns in the chaos of waves and wind? It represents a cosmic understanding so deeply fused with the environment that the sky, the sea, and the vessel became a single, navigable entity. This profound connection to the cosmos through practical wayfinding finds a powerful echo in a very different artifact, one that guided travelers not across water, but across the shifting sands of the Sahara. In the dry savanna of northern Kenya, a circle of stone pillars stands as a quiet monument to an ancient sky watcher culture. These are the Namoratunga Pillars, erected by the Cushitic people over 2,000 years ago. Archaeologists like Lynch and Robbins discovered that these stones are not randomly placed. Their careful geometric arrangement aligns with key stars, including the belt of Orion and the stars of the constellation Triangulum. This was likely a sophisticated calendar carved in stone, designed to track the passage of lunar months and the progression of the seasons. For a pastoral people reliant on cattle, knowing when the rains would come and when the grasslands would be most fertile was a matter of survival. The pillars served as a permanent almanac, where the shifting positions of stars against specific stones would signal the optimal time for migration, for breeding herds, or for holding communal ceremonies. One can envision community elders observing how the shadows cast by the stones at certain moon phases marked auspicious dates, weaving celestial patterns directly into the rhythm of daily life. This knowledge was their greatest tool for adapting to a harsh and unpredictable environment. It speaks to a profound understanding that human prosperity was tied to the cycles of the cosmos, a wisdom that allowed them to thrive where others might merely survive. This African site broadens our perspective, proving that the drive to map the heavens was a truly global human endeavor. That same drive for cosmic order finds a uniquely powerful expression in our next artifact, one forged in the imperial workshops of ancient China. While the Polynesians navigated by waves and stars, a Han Dynasty astronomer was creating a permanent record of the heavens. Around 300 years before the Common Era, Shi Shen and his colleagues compiled a star catalogue of breathtaking scope. This was not a simple list of constellations. It was a precise scientific document that mapped the positions and relative brightness of 800 stars across the night sky. This work, later preserved in texts like the Gan and Shi Astronomy book, became a cornerstone of Chinese science for centuries. Historian Joseph Needham highlighted its profound influence, showing how this cosmic data was woven directly into the fabric of imperial governance and agricultural life. The catalogue's primary function was to enable the creation of an incredibly accurate calendar. By tracking the sun's path against the starry background, Chinese astronomers could define the 24 solar terms, each marking a specific shift in climate and weather. This told farmers the exact right time to sow millet or harvest rice, turning celestial observation into a tool that fed an empire. But the stars spoke of more than just seasons, they spoke of power. The emperor's mandate to rule was believed to be granted by heaven, and celestial events were direct messages about his performance. A comet appearing unexpectedly or a planet moving into a certain constellation was an omen that required interpretation. The Shi Shen catalogue gave court astronomers the reference data they needed to predict these events, most critically solar eclipses. An unpredicted eclipse was a terrifying sign that the emperor had lost heaven's favor, potentially sparking unrest. A correctly forecasted eclipse, however, was a public demonstration of the court's wisdom and its harmonious connection to the cosmos. How did they achieve such precise measurements without a single lens? They relied on an array of sophisticated instruments, including massive armillary spheres built from bronze rings that could track celestial coordinates, and precisely aligned sighting tubes that allowed them to measure star positions with remarkable accuracy. This catalogue represents a tradition of state-sponsored astronomy, a long-term project of cosmic record-keeping that stabilized an empire. This systematic, bureaucratic approach to the stars finds a fascinating parallel in the Roman world, where a different kind of artifact reveals their own unique cosmic vision. A weary marble titan kneels, his muscles straining under the weight of the entire cosmos. The Farnese Atlas, a 2nd-century Roman statue, captures this mythological scene with a stunning scientific twist. The globe he carries is not a smooth, featureless sphere. It is intricately carved with 42 constellations, from the familiar Hercules to the delicate Lyra. This is the oldest known complete depiction of the classical Greek constellations, a celestial map frozen in stone. Scholars like Bradley Schieffer have studied its star positions, finding them remarkably consistent with earlier Greek astronomical records, which the Romans meticulously preserved and adopted. The globe even features a detailed ecliptic circle, the sun's apparent path through the sky, marked with the 12 signs of the zodiac. This was far more than a decorative sculpture for a wealthy Roman's villa. It was a powerful symbol of intellectual and imperial dominance, a declaration that Rome held the very heavens in its grasp. Possessing such an object demonstrated a mastery of cosmic knowledge, linking the owner's authority to the eternal order of the universe. How did this artistic representation influence later generations? Its imagery provided a direct visual link to classical astronomy, a reference point that would help fuel the European Renaissance and shape our modern star charts. The Farnese Atlas stands as a perfect union of myth and science, where a titan's punishment becomes a vessel for human understanding. This classical vision of the cosmos, carved in marble, finds a startlingly different expression in the far north, where another culture saw the same stars through the lens of bone and ivory. The sprawling city of Cahokia rose from the Mississippi floodplain, a metropolis of earthen pyramids and bustling plazas. At its heart, a different kind of monument stood, not of earth but of timber. A series of massive red cedar posts formed a great circle, now called the Cahokia Woodhenge. Built and rebuilt over generations, this was the city's central clock. Archaeologist Warren Whitry deciphered its purpose by studying the pattern of post holes. He realized these posts were not a simple fence, they were a sophisticated solar calendar. On the morning of the equinox, the sun would rise directly over a key post, signaling a moment of perfect balance between day and night. At the summer solstice, it would align with another, marking the longest day. These alignments were not abstract, they dictated the rhythm of life for thousands of people. The largest circle, with its central observation post, likely hosted vast gatherings for planting festivals in the spring. The precise timing of these ceremonies, guided by the sun's position against the wooden posts, ensured the community planted its crops at the most auspicious moment, synchronizing human labor with celestial certainty. This cosmic knowledge was the glue that held society together, transforming astronomy from an esoteric study into a public utility that fostered unity and coordinated survival. What does this tell us about the power of shared observation? In a world before digital clocks, the entire community could look to the same horizon and witness the same cosmic event, a collective experience that reinforced their place in a larger, orderly universe. This practical application of the stars for social cohesion finds a parallel in a different golden age, where scholars turned their eyes to the heavens not with timber, but with brass and precision engineering. A polished brass disc, no larger than an open hand, holds a miniature universe of rotating rings and finely engraved star maps. This is the Islamic Astrolabe, a device perfected by scholars in medieval Baghdad from the 8th century onward. It was a portable observatory, a timepiece, and a spiritual guide all in one. Craftsmen like the famed mathematician Al-Khwarizmi engineered these instruments with interchangeable plates, each one etched with a web of coordinates for a different latitude. By rotating the central retere, a skeletal star map, over one of these plates, a user could simulate the night sky for any hour of any night, past or present. The device could pinpoint the time by measuring the altitude of the sun or a known star, and its back was equipped with an alidade, a sighting rule, to make these precise observations. But its function extended far beyond the practical. Experts like Emily Savage Smith explain how the astrolabe was fundamental to Islamic religious life. Its ability to calculate the Qibla, the sacred direction towards Mecca, meant that a traveler could always orient their prayers, no matter how far from home. It also helped determine the 5 daily prayer times by tracking the sun's journey, and its lunar calendar predictions were essential for marking the beginning and end of holy months like Ramadan. This was a tool that seamlessly wove celestial mathematics into the fabric of daily devotion. How did such a sophisticated instrument spread across the known world? Traders and sailors carried astrolabes on their voyages from the Indian Ocean to the Mediterranean, spreading not just a device but a vast body of astronomical knowledge. It became a bridge between cultures, preserving Greek and Indian innovations while advancing them further. The Islamic astrolabe stands as a powerful testament to an age where scientific inquiry and deep faith were not in conflict, but were partners in a quest to understand a divinely ordered cosmos. This fusion of precision engineering and spiritual purpose finds a stark and powerful echo in a much older object, one carved not from brass but from Nordic stone. A Viking longship cuts through the frigid gray of a North Atlantic fog, a world without horizon or sun. Yet the helmsman holds his course, his secret weapon, a seemingly ordinary piece of clear calcite crystal known as a sunstone. Legends spoke of such tools, but their existence moved from myth to plausible science with the discovery of a piece of Icelandic spar aboard a 16th-century shipwreck off Alderney. This crystal, dating to the Viking Age around 1,000 years into the Common Era, was no mere trinket. Researchers like Guy Roppars demonstrated its remarkable property. By rotating the calcite crystal and looking through it toward a patch of overcast sky, a skilled navigator could detect subtle patterns of polarized light, an invisible signature that revealed the sun's hidden position with surprising accuracy. The crystal would create a double image, and the navigator would turn it until both images matched in brightness, a point that aligned with the sun's direction even when it was completely obscured by cloud. This was not magic, but a profound application of optical physics, a way of seeing the unseen. How did they first stumble upon this property of a specific stone? It speaks to a culture of relentless empirical testing, where survival depended on decoding every possible clue the natural world offered. This knowledge would have been combined with other methods, like observing the flight paths of seabirds known to return to land at dusk, creating a multi-layered navigation system. It was this ingenious adaptability that enabled epic voyages across open ocean to Iceland, Greenland, and even the shores of North America, journeys that would have been impossible with only fair weather navigation. The sunstone represents a cosmic understanding stripped to its most practical and brilliant essence, using the very physics of light itself as a compass. This pragmatic mastery of the heavens finds a final, breathtaking expression not in a tool, but in an entire building designed to capture the cosmos. We return to that intricate bronze machine, the Antikythera Mechanism, to uncover one of its most brilliant secrets, a detailed lunar theory encoded in its gears. Deep within its clockwork, researchers found a pair of small gears linked by a cunning pin and slot device. This was not just for counting days, it was a physical model of the moon's elliptical orbit. As the gears turned, the pin slid back and forth within the slot, subtly speeding up and slowing down the rotation of the moon pointer. This ingeniously mimicked the real lunar anomaly, the fact that the moon moves faster when it is closer to Earth in its elliptical path and slower when it is farther away. The mechanism did not just show the moon's position, it accurately represented its varying speed across the sky. This subtle correction was then integrated with its eclipse prediction dial. The device could forecast not just when an eclipse might occur, but whether it would be lunar or solar, and even its likely magnitude and timing. This reveals a grasp of orbital mechanics that historians once believed was impossible for its time. How did the Greeks of the 2nd century before the Common Era develop such a profound mechanical insight? The pin and slot mechanism is a work of pure genius, a conceptual leap that translates abstract astronomical observation into tangible, moving metal. It suggests a lineage of scientific thought and engineering experimentation that was almost entirely lost to history. This single component, smaller than a modern coin, encapsulates an ancient understanding of cosmic order, so advanced it would not be matched in Europe for well over 1,000 years. As we conclude our journey through these 20 artifacts, from desert drawings to golden discs, a unifying truth emerges. These were not separate cultures groping in the dark. They were participants in a shared, global human endeavor to read the grandest story ever told, the story of the cosmos itself. These 20 artifacts form a chorus of voices from across the ages, each singing the same fundamental truth. Our ancestors did not see a gap between the observatory and the temple, between the mathematician's calculation and the priest's prayer. They built a single, unified worldview where the stars guided the plow, the solstice dictated the law, and the moon's phases measured both time and the favor of the gods. This was not a primitive superstition, but a holistic science of survival and meaning. Visionaries like Carl Sagan often reflected on this universal human trait, this insatiable curiosity to find our place within the grand cosmos. What these discoveries challenge most profoundly is the comforting idea of linear progress, the assumption that knowledge always moves in a straight line from simple to complex. The Antikythera Mechanism, with its differential gears, and the Babylonian Venus tablets, with their precise orbital periods, demonstrate moments of technical brilliance that, in some cases, would not be replicated for more than a millennium. This suggests not a steady climb, but a landscape of innovation where peaks of understanding could rise and then be lost to time, only to be rediscovered later. Perhaps their greatest lesson for us today lies in this integrated perspective. They did not treat the sky as a separate object to be dissected, but as a living system of which they were an active part. Their cosmic understanding was woven directly into agriculture, governance, art, and spirituality, creating a resilient framework for society. As we face our own global challenges, from environmental shifts to a sense of cultural disconnection, might we find wisdom in their example? Could reconnecting our own advanced science with a deeper sense of purpose and place offer a path forward? These artifacts are more than historical wonders. They are invitations to remember a more connected way of being, a legacy written in bronze, stone, and starlight that still has much to teach us. These scattered artifacts are not isolated wonders, but threads from a single, vast tapestry of ancient intellect. The true power of this cosmic knowledge was not in the objects themselves, but in how they shaped the very foundations of civilization. From the deserts of Peru to the plains of Mesopotamia, societies rose and thrived by weaving the rhythms of the sky directly into the fabric of daily life. This was a global phenomenon, a shared human project where understanding the cosmos was synonymous with survival and meaning. Historians like Clive Ruggles have mapped this profound connection, revealing how astronomy was the ultimate practical science. For the Maya, the precise cycles of Venus dictated the timing of warfare and royal ceremonies, turning celestial mechanics into statecraft. For the Inca, a temple aligned with the solstice was not just an observatory, it was a mechanism to maintain cosmic order and ensure the sun's return. This deep integration enabled agriculture on a massive scale, allowing cultures to coordinate planting and harvest across entire regions by following a celestial calendar everyone could see. It created a shared sense of time, a communal rhythm that bound people together under a common sky. The guardians of this knowledge were often priestly classes, individuals who dedicated their lives to observing, recording, and interpreting the heavens. They were the ancient world's scientists and engineers, preserving intricate data on eclipses and planetary motions across countless generations through oral traditions and fragile manuscripts. This wisdom was not static, it traveled. Along the Silk Road and other ancient trade routes, ideas flowed as freely as spices and silk. Babylonian lunar observations, meticulously recorded on clay tablets, found their way to Greece, influencing and enriching the work of astronomers there. This was a cross-cultural fertilization of knowledge, where each civilization added its own insights to a growing body of cosmic understanding. What does this tell us about the role of cosmic observation in human development? It was the ultimate enabling technology. These astronomical systems provided the stable, predictable framework necessary for large-scale societies to organize labor, manage resources, and develop complex cultures. They answered fundamental human needs for order, purpose, and connection. The sky was humanity's first clock, its first calendar, and its most enduring map. This interconnected web of ancient wisdom challenges us to see our ancestors not as primitive stargazers, but as pioneering scientists who understood that to look up was to find their way forward. Our journey across continents and millennia reveals a profound truth, that our ancestors saw the cosmos with a clarity that often rivaled our own. From the intricate bronze gears of the Antikythera Mechanism to the vast desert lines of Nazca, these 20 artifacts are not merely relics. They are testaments to human ingenuity, each one a brilliant spark of insight into the grand mechanics of the universe. These were not primitive people groping in the dark, but keen observers and engineers who encoded their understanding into everything from portable calculators to monumental architecture. Their work challenges the very notion of linear progress, showing us that profound knowledge can emerge, be lost, and then be wondrously rediscovered. The astronomer Carl Sagan beautifully observed that we are a way for the cosmos to know itself. These artifacts are the enduring proof of that ancient, universal quest. They represent a time when science and spirituality were woven together, creating a worldview where humanity was an active participant in a living, orderly cosmos. This legacy of curiosity is a gift passed down to us. Which of these 20 artifacts left you the most amazed? Share your thoughts in the comments below. If this exploration into historical mysteries resonated with you, subscribe for more journeys that look to the past to enlighten our future. Let us carry this legacy of wonder forward, forever looking up at the stars with the same insatiable curiosity that guided our ancestors.